Good morning everyone, this is Asha from the Department of Mechanical Engineering, Global Academy of Technology. In today's session, I will be discussing on special case of Routh array. In the previous lecture, you have seen how to solve the Routh array if the first element of any row of the Routh array is 0. In today's session, we will be learning how to solve the special case of Routh array if all the elements of any row of the Routh array are 0. So if we encounter in any row of the Routh array table, if all the row elements are equal to 0, then it is considered as special type of Routh array. So first you need to form an auxiliary equation using the coefficients of a row just above the row of zeros. Then take the derivative of an auxiliary equation with respect to s and replace the row of zeros with the coefficients of derivative of the auxiliary equation and complete the Routh's array in the usual manner and ascertain the stability of the system. So let's look into the problem. It says that ascertain the stability of the system. You have been given the characteristic equation. So start writing the Routh array table by looking into the equation. The highest power in this equation is s to the power of 6. So start writing the Routh table starting from s to the power of 6, then s to the power of 5, s to the power of 4, s to the power of 3, s to the power of square, s to the power of 1 and s to the power of 0. First two rows can be filled by looking into this characteristic equation. The highest power is given as s to the power of 6. So write the coefficients of even power of the equation. That is the coefficients of the even power in this characteristic equation. That is 1, 5, 8 and 4. Second row is the coefficients of odd powers in this characteristic equation. That is 3, 9, 6 and 0. So s to the power of 4, the values can be got as 3 into 5 minus 9 into 1 divided by 3. That is the value of B1. That will lead to 2. Then B2 value is 3 into 8 minus 6 into 1 divided by 3. That will be equal to 6. And B3 is 3 into 4 minus 0 into 1 divided by 3. That will be equal to 4. So we have got 2, 6, 4. There is no fifth column, so value is equal to 0. S to the power of cube values can be got as 2 into 9. That is, we have C1 value 2 into 9 minus 6 into 3 divided by 2. So it is 18 minus 18 will be equal to 0. Again C2 value can be got as 2 into 6 minus 4 into 3 by 2. So it is 12 minus 12, it is 0. C3 value, we have 2 into 0 minus 0 into 3 by 2, that is 0. See, S cube row has got all the values as 0 elements in that row. So whenever you encounter a problem like this, it is a case of special type of Routh array. Okay, so in that case you have to see a row before that. From this row form an auxiliary equation. So the coefficients is here, it is s to the power of 4. So it is 2 into s to the power of 4 plus 6 into s square plus 4 will be equal to 0. So this is my auxiliary equation. So I have got the auxiliary equation. Now I get the derivative of that. So it will be 8s cube plus 12s. So in s cube row, write these coefficients 8 and 12, 0 and 0. So the next s square can be got as 8 into 6 minus 12 into 2 by 8, that is 3. 8 into 4 minus 0 into 2 by 8 is 4. Again 8 into 0 minus 0 into 2 by 8 is 0. Similarly, get the value of S1, that is 3 into 12 minus 8 into 4 by 3. So 3 into 12 by 4 into 8 by 3, that is 1.33. Again for s to the power of 0, it is 1.33 into 4 minus 0 into 3 by 1.33, that is equal to 4. If you observe all the elements of the first column, all are positive in nature. There is no sign change. So, solving the auxiliary equation, we have got that auxiliary equation. Now put s square is equal to x. The equation becomes 2x square plus 6x plus 4 is equal to 0. Get the root of the equation, substitute in x and get the value of s. We have got the value of s as plus or minus I, and s is equal to plus or minus I root 2. These roots are also the roots of the characteristic equations, and these are not repetitive. These are not the same values with no positive real part. There is no positive real part present in this. So it is only the imaginary part, and hence the system is marginally stable. So we have solved the special case of Routh array by framing an auxiliary equation and getting the derivative and substituting the coefficients of that derivative in the row which is having completely 0 and checking the stability of the system. Thank you.